Okay, one last example. We're going to graph this function. The first thing we have to do is to factorize both the numerator and the denominator. Notice that both of them are already linear expressions, so there's nothing left to do. So the first thing I'm gonna do is to find the domain. And the domain for this function is all real numbers except the ones that make my denominator 0. So if I grab my denominator, equate it to 0, and solve for x, I'm gonna find the invalid values for this function. And remember, the vertical asymptotes are exactly the equations for those invalid values. Remember, the asymptotes are equations. So, in this case, I'm only going to have a vertical asymptote that crosses through 2. Now, the next thing we have to find is the X-intercept and Y-intercept. So, to find the X-intercept, remember, I have to find the zeros from the numerator. So I graph my numerator, equate it to 0, and solve for x. So my X-intercept is 3, meaning my function can only cross the x-axis through that point. My numerator is a linear polynomial, meaning I will only have one is the X-intercept. Now, the y-intercept is found by evaluating the function in 0. So if I evaluate the function in 0, I have that this is 0 minus 6 over 0 minus 2, meaning 3. So the y-intercept is in 3, meaning my function is going to cross the y-axis only in this point. Lastly, we're going to find the horizontal asymptote. The degree of the polynomial in the numerator is 1, and the degree in the polynomial of the denominator is 1, meaning that the horizontal asymptote is going to be the division of the leading coefficients. So the horizontal asymptote is going to be defined by the division of the leading coefficient. The leading coefficient for polynomial in numerator is 2, and for the polynomial in the numerator is 1. So 2 over 1 is 2. So my horizontal asymptote is the equation y equals 2. So there's all the info I have. Now again, to start graphing my function, I'm going to choose a side. Notice that I only have two sides because I have a single vertical asymptote. So I can start in any place I like. I'm going to start on this side. On this side, notice that 3 is a close number to the vertical asymptote that is in 2. And in 3, we have an x-intercept, meaning our function is going to cross through here. So because I know it's going to cross through here, and we know that asymptotes attract the graph, the only way for my graph to go is to go to minus infinity and get close to the horizontal asymptote and never cross it. Another way to verify this is to evaluate. For example, let's evaluate in a number between 2 and 3. For example, 2.5. So if I evaluate my function in 2.5, or in other words, 5 halves, that would mean this would be 2 times 5 halves minus 6 over 5 halves minus 2. This would be 5 minus 6 over 1 half. This would be minus 1 over 1 half. And this would be, applying sandwich law, this would be minus 2. So for 2.5, my function is going to cross in minus 2. So as we can verify, if I get closer to my vertical asymptote on this side of the plane, that function is going to go into negative values, thus going into negative infinity. And if you want to know if how the function gets closer to the horizontal asymptote, just evaluate in a number you like. For example, in 6. If I evaluate the function in 6, this is going to be 12 minus 6 over 6 minus 2. This is 6/4 or 3/2. So the coordinate 6, 3/2 is 6, 3/2, o sea, 1.5, is here. So my function is going to effectively have this behavior on this side of the plane. Now, on this side of the plane, I know here's a y-intercept, so my function can only cross the y-intercept here. Because this number is already close to the horizontal asymptote, I know my function has no other way but to go and get close to this asymptote. Now, to find what happens here, there are two ways to look at it. Either to evaluate the function in 1 to see if the number is positive or negative, or to notice that my function can never go in this place to minus negative, because that would mean my function would cross the x-axis, and we do not have an x-intercept in this region. So that means my function has no other way but to go upwards. To verify this, we're going to evaluate in a number close to the vertical asymptote. My vertical asymptote is in 2, so I'm going to evaluate in a number close to it on this area of the plane. So in 1, f of 1 is 2 minus 6 over 1 minus 2, and this is minus 4 over minus 1, meaning 4. So the coordinate point is 1, 4. In 1, my function is 4. 4 is positive, and it's close to the vertical asymptote, so I have to go to positive infinity. And that's it. That's how we graph rational functions.